So I'm Jim McHugh, Vice President of UCS and Data Center Solutions Marketing, and Raghu is the real brains up here.
Yeah, I'm Raghu Nambiar. I've been leading the Big Data Charter for the Cisco Data Center Business Group.
So I think maybe instead of us just start speaking at you, why don't you guys, what do you have questions about in the big data space? Why don't we kind of capture those and make sure we tick them off? Do you want to hear more on the infrastructure standpoint? Do you want to know more about our partnerships? Do you want to see how we view the market space? I mean, we could spew endless customer examples or case studies at you. But what do you guys need to help you in this next 30 minutes we have together?
So for me, it's very strange that an infrastructure company, hardware company, mostly hardware company, is talking about big data. The big names in big data are, even when we talk about infrastructure big data, we talk about Cloudera or Autonomous. So what's your role in this big data position?
I've been lucky enough to have been sitting in the back through the last two presenters. And it's been very strange to you in particular that applications have changed and then that we have to deal with these applications differently. And that is the biggest change that we're all going through. So I'm going to tell you my background. I'm an application guy. I actually used to run Solaris, which someone talked about ran and when he gave that example, that was a Solaris machine because I can tell you AIX is still not running that good. But the basic gist is this. Applications, and Todd was leaning on this, have changed so much that they're at the edge. So we could talk about the IoT type applications, et cetera, and how those get written. We could talk about what's going on in your data center and the changes that are going on with just SAP apps, with what HANA is trying to do and the changes they're doing, or as apps get rewritten so they can be in a public or private cloud. And people are choosing OpenStack because they want to rewrite their application in a different way and they're trying to accomplish different things, or they're going for Microsoft. So it's the applications and the availability of data that are really powering those applications that are changing. Now, as an infrastructure company, we actually offer infrastructure across the board, end-to-end, that allows you to do that. You could go with an appliance-type model for some of these. You could go with a hyper-converged model for some of these. But the value that we have is we can let you manage from a central way your solutions at the edge, in a public cloud, in a private cloud, in a remote branch office. And by taking that approach, we are continually growing. And so their customer base and what we're hearing from our partners and our channels, that's what they're looking at. But the reality is applications have changed. Our need is to understand what takes a big data solution. Where you started with was the data management aspect of it. So yes, we have great relationships with Horton, MapR, Cloudera. We actually have resale agreements with them because actually we found more and more, an average data management solution with a Hadoop deployment was taking 6 to 9 months and it was a real pain. So if you engage with them, you understand what it takes to do the deployments, you actually come together with UCS integrated infrastructure, we're shortening that. We're giving the reliability.
So how are you shortening that? So bringing that from the 9 months down, what's your part of the shortening that time period?
So let me step back and comment on your question about the infrastructure. If you look at the big data, of course, that is a data management stack. That's application stack on top of that. Then you have infrastructure. If you look at the recent Gartner or IDC report, 52% of the big data spending is going to be on infrastructure through 2018. The reason is the stacks above that, like especially the data management stack, it is developed in open source and it is going to be much cheaper than the traditional systems. So one comparison is if you want to store 1 terabyte of data on an enterprise data warehouse like Teradata or Oracle Exadata, it is going to cost you anywhere from $30,000 to $50,000 per terabyte. Okay, that includes hardware, software, and service. Okay. On the other hand, if you look at Hadoop or NoSQL distributions that is developed in the open source community, it is going to cost you under $1,000 per terabyte. So significant difference. But big data is like exciting from a technology perspective, but very new to a lot of our customers. So to your question, like how do we shorten that cycle?
What's your part of it?
Yeah, so the first of all, we provide the infrastructure platform. Second thing is we developed new software called UCS Director Express. Okay, so that is a one-click deployment tool. You can provision UCS servers, install operating system, install Hadoop distribution of your choice. Like we are supporting MapR, Cloudera, and Hortonworks now. In one click, you can have your Hadoop infrastructure ready to go. Okay, so all these complexities, right? What platform to pick, what operating system, what Hadoop distribution, how do you tune and tweak? We have taken all the complexities away, and UCS Data Express will be able to do that in one click.
So I have a question. So you put out these numbers from IDC, and we know that traditional data warehouse was very costly. Most of the reason. Now, most of the costs in the Hadoop clusters, right now, you roll a lot, is storage. Because you need to build these huge data lakes. Okay? So you need to find very cheap storage. And you need to access small data sets in huge storage space. And this is where some object storage vendors are going, and they are doing everything with the cheapest hardware on the market. Okay. The computational part
Cheapest storage hardware. Sorry?
Like cheapest storage hardware is what you're saying, yes.
Also servers. They are buying cheap servers, sometimes with 60 or more disks, because they need more space than performance. And if they need performance at the stage is throughput and not items. Okay. So most of these clusters are now splitting. So at the beginning it was HDFS into the cluster nodes. Now someone is starting. Hortonworks has certified a few days ago an object storage vendor to be. And so these clusters are splitting because if you need to store petabytes and petabytes of storage, the nodes can keep up with that, especially because HDFS has some problems. So the computational part is becoming smaller, smaller, and smaller. Probably most of the nodes will have an amount of SSDs to process information faster, but it's really not that big. So it's again, it's not about bringing up so the cost is not in the infrastructure. Eventually, it is also in the infrastructure.
Mostly on the storage. That's your point, right? So if you look at like HDFS, as you said, right, the model is you take the data set and distribute across like large number of nodes and do concurrent processing, okay? And you have the compute and storage together, right? In traditional application, you have a compute and SAN storage. Here, with Hadoop and any other distributed processing model, you have a compute and storage together. So if you look at our solution, what we have done is we have taken our C240 server. It's a 2RU server with the 2 CPUs with an option of 24 small form factor disks or 12 large form factor disks. The first one for performance, second one for capacity.
So we are already seeing that it's not enough to that Internet of Things kind of stuff. So if you have millions and millions sensors every hour.
So if you look at the capacity perspective, the capacity intensive model, we support 12 disks. Okay, with the 6 terabyte disks, you're talking about 72 terabyte of storage capacity in 2RU. Okay. In addition to that, we have introduced a new product called C3160. It's a 4RU box with the 2 CPUs with the 60 large form factor disks. So 60 times 6. So 360 terabyte of storage capacity can be supported in 4RU. If you put 10 of them in one rack, you're talking about 3.6 terabyte of storage capacity.
Yeah. So 1/3 of that because HDFS
If your application,
okay, so it's 100 terabytes, not 300. And at the end of the day, it's not enough. Because if you are, I have customers just in Italy, so small companies, they are producing more than, so at the end of the day, they are already producing more than 30,000 billions, 30 billion lines of logs every 6-7 months.
Okay.
And they are throwing that away because they do not have space. They are complex logs, of course, they are not only lines, there are some. And we are saying that you are going to solve that. We need more storage. So bigger, probably bigger disks, so 10 terabyte disk or that, and then they need to add storage at a different level than CPUs. So we don't need 2 CPUs every 100 terabyte of storage. We need 2 CPUs because the number of data we calculate, we compute, is always the same. So the quantity of data or the data set is always the same. But theoretically, we need much more storage because it's cutting out.
How is that their problem?
Yeah,
Isn't that a storage?
Let's back up. I think what Raghu laid out is, and really addressing a lot of customer problems, is as they're starting in their big data deployments, right? We actually, if you're looking at the typical Hadoop data lake situation and where people are falling down, is it's where they start it and then they try to scale out from there. And I always give the example, if you grew up dealing with Oracle databases and the little known problem that if you didn't have a consistent architecture, even if you grew your Oracle database, that little bug started hurting performance. Ask Raghu about the deployments he walked into where they took their Hadoop deployments and tried to scale them out and didn't have consistency. That's where we start adding a lot of value. When you're getting to your level and the things you're building out, we could throw out examples of CERN and the amount of terabytes they actually create per second as they study the universe, right? All on OpenStack, by the way, as their basis for it. So we can always find where the architecture and the infrastructure and the software is doing well and where it's not. And it's usually because you're not having a consistent way of building it out. So, you know, I would look at this from the standpoint of, yes, your customer definitely is having great storage components. What they need is a model of having what's their hot data, what's their medium and cold. And they're going to have to find a way to store away some of the stuff and be able to go get it, which means they're going to have to build out their data lake in a Hadoop situation and have that continuously grow. That's not unlike most customers we see, where they're actually found a use case. That use case went well. Now it's time to expand to another department, and so I have to grow that data lake. It's a very interesting stage for every customer where they could actually start killing that deployment or actually, you know, making it grow consistently, build out. And that's where infrastructure is extremely important. And a lot of people who have gone white box and a lot of people who have gone completely commodity either have some really smart guy working on that or they're having problems. And I'll give you 2 examples of people who focus on it from an online standpoint. Altascale has $30 million in investment. Databricks, the guys who are leading all the Spark stuff, have equal to that. They spend a lot of time just keeping up their customers' deployments, and they're supposed to be the most experts in it. So when you start rolling it out, if you're just going to be using this kind of commodity type stuff, you better be damn good, right? And you're basing your customers' examples on that. So that's my little soapbox. I know you got to follow on that.
Yeah, absolutely. I mean, you know, so the consistency in deployment is extremely important because the scenario you just mentioned, you know, you do distribute the data across multiple nodes and to do concurrent processing, right? And your performance will be bound by the performance of the slower node. The slower node could be like a incorrect CPU setting, okay, or incorrect RAID setting, okay. So with the UCS, what we guarantee is consistency in configuration from across all the nodes, because you start with a service profile which has like all the information how to tune your server for the particular application. Okay, so consistency is pretty much guaranteed. Second thing is you start with the 16 nodes today or 30 nodes today, and tomorrow you want to add another 10 nodes, 20 nodes. Okay, what you do is you replicate a service profile and blast on the new system. So those new systems will be part of your cluster in quickly, and more importantly, it will be consistent with the configuration that you have you had before.
And I think another really smart point that you mentioned earlier was the sensors and how they're coming on. I don't think a lot of that sensor stuff is going to be centralized back. I think we're going to a model where people are actually going to have data virtualization approaches, or they're going to do some component of, on the manufacturing floor, the likelihood of that part failing is going to be communicated on the manufacturing floor. But then at the same time, a really smart manufacturer is keeping all the historic stock data, repair cost, when you get into manufacturing, it's manpower, machines, and materials. And they're going to be able to make that smart big data decision. Okay, that machine's probably going to go down. Should I replace it a whole way? Or should I get a part out there? Well, if I can get a part out there, do I have it in stock? And do I have the manpower on location who can go change it? So it's not just big data giving you insight, it's leading you to the action that you can take. So, you're going to separate that problem and then collate it through a data virtualization component so you can actually make the decision without moving this data around. Oil rigs, you're never going to move all that data off an oil rig, right? We can go example, retail experience. I actually want to track via MAC addresses when someone's coming in and give them promotion and start tracking their way they're going through the store. But I'm also going to be centralizing data over time back into a central location where I'm going to start studying buying, patterns, et cetera, that are going to help me understand what sizes, what types of clothes, what types of things that I'm actually going to stock in this location versus this location. And I'm going to tie it back into another data center, which is going to tell me my supply chain. All these things are becoming a very distributed big data and bringing our customers solutions. And people tend to think big data, I've got the big data lake in the sky, just one. No, there's several. Just like there's several cloud options. I may run Azure apps, I may run SAP, or I may run Oracle in my core, and I may use, a whole different component for Salesforce.com or newer cutting edge apps. The world is saying don't standardize. In my world, that's what I would go. From an app standpoint, I would choose the best app, I would choose the best infrastructure software to run it on, and then what's the right infrastructure in each location. So in one way, in the IT space, our job gets harder and it's more complex. From the end user standpoint, their life's getting better. And, I think it's what's exciting about our industry right now, to tell you the truth.
Any other questions around big data? And I can spend a few minutes on our partner ecosystem, if you like.
I kind of drew up here the whole idea of data management, the data integration, our analytics partners. One of the hottest things I see coming is the Spark, and why that's great for us is because it's very in-memory intensive. The performance is so much better than a lot of the batch processing that went on through, MapReduce several years ago. You found Cloudera was the first to jump, Horton's on board, MapR's on board, and that sort of deployment in a UCS with an intense memory is actually just really well.
Yeah, we have our standard CT40 servers. We support up to 768 gig of memory, and our 460, P460 and C460, there are four CPU boxes. We can support up to 6 terabyte of memory. It's one of the industry most dense configuration available in the industry.
So you hit on one topic that Peter, Paul, and Sam and I, we've had many discussions on at the other wireless field day events and retail analytics. Meraki does a great thing with their offering you the ability to opt out, because this whole monetizing Wi-Fi is kind of either you're for it or you're against it. There's a clear line drawn in the sand in it. And as we start approaching big data, and you're kind of talking about, well, maybe not necessarily we're going to have all of this data leave that site and go up into a centralized model. It's going to be distributed. How are you guys going to be able to help develop the tools for like CMX where we can offer that same similar opt-out process so that if I don't want you tracking my phone, I mean, I leave my Wi-Fi off now, and I'm a wireless engineer, but I leave it off so I'm not tracked. I mean, how are you going to be able to offer a similar type of process of opting out if you're saying, no, just leave the data, to a store specific or to, a region specific, and we don't have somewhere that we can go and check in and say, should I even track this person or not? Have they opted out?
So if you opt out, that's a decision you take, okay? We can't do much. But if you opt in, okay, then we can use the data. Okay.
But that's the problem is that you're not taking the opt-in approach. You're taking the, I'm just going to track you and I don't bloody care what is going on, because that's what the default setting is in a CMX land is that there is no opt-out today.
You mean it's the MAC address tracking as opposed to I'm going to let you know who I am.
Talking about your partnership with Funware or anything where you're building an app on the phone and you're tying it to a loyalty database, and now you've got your CRM attached to that MAC address so you actually know who I am. I'm just talking about the random tracking of it as a whole, as just that creepy aspect of, the creeper aspect of, oh, you're watching me walk around your store and I'm going to this, I'm going to shoes, I'm going to pants, I'm going to...
Well, big data in general.
Yeah,
right.
Big data in general is kind of a creeper stance. And it's, how are you going to build the tools so that it's not a opt-in and, oh, if you're lucky, maybe we'll give you an opt-out? Yeah,
so you are dealing with, and I think it's an interesting debate that takes place in different geographies, anonymized data or not, right? Because a lot of people will come to the standpoint, I don't really care if it's anonymized. I would be happy if they were using my data but didn't know who I was at a sporting event, and if I knew I came up to the stand, turned right, I can get a beer a lot faster than if I turned left, because they're actually doing tracking of the lines. I'm actually very comfortable if it was truly anonymized, they were using my healthcare treatment data, and actually this process of treatment works a lot better for that rash or whatever it is than this one does. And by studying thousands and hundreds of thousands of people, they can get to that. I'm okay with that. I personally am not an opt-in, I'm in your store, my name's Jim McHugh, and yes, you are now able to know I bought this from an online store, and no, I really don't want somebody to walk up and tell me this sweater will match better with that shirt I bought. Some people do want that. So that's the first level, so I think it gets to a point where people are going to have to get comfortable. I do scan the loyalty thing at grocery stores. I don't care if they know I buy, almond butter and wheat bread or not. It's not going to change, going from there. But that's a cultural thing, and it really is geographically different. I think in the U.S., people are much more open to it. Some countries in Europe, Norway, with the stadium experience, they're all over it. They think it's a great thing because you start seeing the benefit. It's like, if I give you this, what do I get in return?
There's always the benefit discussion. That's definitely not a problem. Look at stadium's a perfect example of the blue dot. How do I get from point A to point B is fast enough? Cisco Live. You guys wanted to do an IoT thing for Cisco Live. Yes, Matt, you can drink. You should have tracked to see which bathroom has the most lines in it so that guys can actually figure out where to go, because it's a hard thing to do here.
Or women.
Well, women's bathrooms in conferences, unfortunately, are, yeah, there's not a lot of women in tech, which you need to fix. But it's, from the point is that I don't necessarily want somebody to track that I'm, in the store, I'm in this zone, I'm walking through this way. But I agree, I will track or let them track and say, okay, I've purchased this product and this product and this product, and let your guy that's analyzing the data try to figure out an algorithm as to why I bought that. I mean, there's times I order things on Amazon and I'm just like, have fun trying to analyze this and figure out what was the reasoning behind buying these two different things. It was more of a just, I needed two different things, so I'm going to purchase it in the same order. But when we get into the point of tracking you and actually watching your flow,
how much of that is a technology issue rather than a process and legislation issue? I don't think technology should be limited by.
No, I don't think it should be. I don't think it should be limited, but I think there's always got to be the opt out, and that's what that's the two different approaches. So Meraki has the opt out.
Technically, do choose an anonymity or not? You can't do that from physical. It either tracks who you are or it doesn't.
Actually, it either tracks your MAC address or it doesn't.
But I mean,
That's the thing.
I have no choice with my MAC address to tell you if I want to give you my data anonymous or not.
Meraki does.
Right?
Meraki.com/trust. And you can opt out, and you will never be tracked in a single Meraki
I want to be able to be
instance.
tracked anonymously.
But that's
You can't
different.
do that. That choice is something you cannot make with.
You're raising it. I mean, at some point, there will be, I would like to be on Wi-Fi, but I don't want them to know I'm standing in front of this end cap for the last 15 minutes. Other people are going to want them to know there, because if I'm standing there and all of a sudden I get a, hey, are you interested in 15% off that? Boom.
That's BLE. That's doing it different ways and based off it. Yeah.
Take it, but what you're asking for, and we may get there, it may be legislated, it may not be, that yes, customers have the right to Wi-Fi without being tracked.
Yeah, it's just the discussions that come up with us.
I'm a little bit more in your camp, and it's a cultural thing. It's not really a technology. I think my MAC address is anonymized. I mean, unless it can then quickly convert, if AT&T or Orange or Virgin starts selling who I am, and then I can be taken out by a drone, then yeah, maybe then I'll start being worried. But for now, I'm actually quite comfortable with it. But other people aren't. I get it. So we didn't go into it, but we're going to be doing a benchmark that just came out, and we put a lot out on that recently, which is pretty impressive. We were doing webinars with the top data management guys, the data integration guys, as well as the analytics. We have partnerships with the like of Splunk, Platform, SAS, SAP. We spent a lot of time working out what the industry, challenges are and what are the infrastructure requirements to get there. I don't know if you want to, in the last couple of minutes, talk about the benchmark.
Sure, yeah. So, a lot of customers were challenged with what kind of platform to pick for big data in terms of performance, price performance, and energy efficiency. So there are a lot of claims by vendors, so not easily verifiable. So the industry standard committee, TPC, Transaction Processing Performance Council, has developed a new benchmark for benchmarking big data systems. The benchmark is called TPC-XHS. The same committee that developed TPCC and the TPC-D benchmarks in the 90s. The new benchmark is designed to measure the performance of big data systems, especially Hadoop systems. It became a standard last year, 2014 August timeframe, and Cisco is the first company to publish benchmarks with that standard. And we published 3 benchmark results, one at 1 terabyte, 3 terabyte, and 10 terabyte, showing the performance and scaling of UCS integrated infrastructure for big data. We're pretty excited about that. I mean, we're the first one to publish, benchmark in this emerging space.
It is going to be this not one size fits all. That's why there's so many different. And we talked about data management. We talked only about the Hadoop guys. Mm-hmm. NoSQL is doing just fine right now, honestly, and so is the MPP guys. I mean, so. And when we look at our analytics partners, the variety between Splunk, which is going to be here at the show, you should spend some time with them, what they do with the machine data and with newcomers like Platform and like people like SAS that have been in this for a long time, they're really supporting so many different opportunities because of the ways they approach the technology and trying to get to it. So.
Yeah, it's going to be exciting. I mean, there are a lot of analytics with the new generation of new type of data, like recommendation engines, personalized services. In addition to that, like a lot of when it becomes critical in the enterprise. So the integration of these new data sets, new analytics with existing like SAS and SAP is also important. So we have been closely with not only these emerging players but also traditional players to bring the next generation analytics to you.